Chapter 6 is on graphing, which seems like it should be easy. And as always, they figure out ways to make it hard, to give you the hardest stuff. You've been graphing since first grade, right? So one of the things that you're going to graph towards later in the problems is you're going to have to deal with circles. Okay, so we all know that a circle looks like this: x squared plus y squared equals the radius squared. That's if it's centered at the origin. So let's just play with the easiest one, centered at 0, 0. If it's not, if the x value is different, right, you subtract whatever it is from the x value or the y value. Now, normally you write a function as y, right? Y equals f of x. So y, the height on the graph, is some function of x. So let's solve for y here. So y squared is r squared minus x squared. Take the square root of both sides. And y is equal to plus or minus, right? Don't forget the plus or minus, r squared minus x squared. And again, that's if it's centered on the origin. So, this is not a function because it's plus or minus. There's two values, right? We already talked about how a function has to only have one value. For every x, there's one y, but we have a plus or minus. Because remember, if we square this, we square this. If it's negative squared, we get this back. If it's positive squared, we still get that back, and that squared, same thing. So that's why you have to have the plus or minus. So what you do is you got to choose one or the other. Okay? If we choose the plus sign, then it's the top half of the circle when y is positive, right? Because it's centered at the origin. So when y is positive, it's the top half. And if y is negative, it's the bottom half. So you choose one or the other. So if you want the top half of the circle, it's called, of course, a semicircle. Half, semi means half. So you choose the positive one. If you want the bottom half, it's a negative one. So if you need to know the formula for the bottom half of a circle, it's this negative square root of r squared minus x squared. Top half, it's positive. Look for this formula. Remember this. If you see it somewhere, square root of something, a number minus x squared, you know it's a circle or a semicircle, either the top or the bottom. Okay, that's one type of function that's tricky to graph. The other ones are multi-part functions, where you have a function defined for only different domains of x, where from x equals -3 to for 0, it's this. From 0 to 5, it's this. From 5 to infinity, it's this. So you define it with multiple things. That way you can make interesting stuff. You can make it part of it a parabola, part of it a straight line, part of it something else by having a multi-part function. So that's going to be the main gist of this chapter, having our function to have multiple parts. And the basic one, or one that they focus on a lot, is the absolute value function. So yeah, and I'm going to put that up here for problem number 1 here. So problem number 1, we have, right, they graphed it for us, the absolute value of x, which means x is never negative. Right, absolute value means we just always make it positive. So here, when y equals x, the regular line is this, right? But oops, it's negative, so instead you bounce back up. It can never be negative. The way you deal with absolute values is you get rid of the absolute value. That's how you deal with absolute values. You get rid of it, because how can you do math with bars around? It's too complicated. So you get rid of it. The way you get rid of it is you make a multi-part function like they did here. Absolute value is weird, but instead you say, okay, it's just regular old x if x is less, if 0 is less than x, okay? So that's this, or x is greater than 0. It's kind of backwards the way they write it, huh? If x is greater than or equal to 0, it's just regular old x. That's this part. If x is less than 0, it's negative of x. So if x is less than 0, which means x is negative, negative x makes it positive. So that's this part, right? So like here, maybe x is -1, so negative of x is 1. So this is 1. So again, the way they got rid of the absolute value is just to make it, leave whatever's inside, and this is the big trick. Whatever's inside, you put here, and then figure out what x has to be, so you don't need the absolute value. And then when you need the absolute value, when it's negative, you make it negative, and then you don't need the absolute value either. That way it's always positive. When x is negative, you make it negative to make it positive. When x is always positive, you don't need the absolute value. So the trick to absolute values is break it up into 2 domains. One sets of x's where you don't need the absolute value because it's always positive. And then the range of x's where, or I should say the domain of x's, where it's going to be negative, so you make that the function negative there to force it to be positive. That's the big trick, okay? So anyway, that's what absolute value looks like. So let's look at problem number 1. It says calculate absolute value. Of course, that's easy. Just get rid of the negatives, right? Absolute value gets rid of the negatives. Then they say something like solve for absolute value of x is equal to 4. Okay, absolute value of x is equal to 4. So there's two ways to do it. You could look at the graph and say, okay, here's the absolute value of x. Here is y equals 4. Right, y equals 4. It crosses right there at 4. So what is this point and what is that point, right? What is x for the absolute value is equal to 4? So what is this x and what is this x? Well, obviously there's two answers. There's two places where the absolute value is equal to 4. There's this one here and that one here. So we use this formula, absolute value of x equal to 4. So if x is greater than or equal to 0, it's x. If it's less than or equal to 0, it's negative x. So obviously x would be negative 4 and 4. So the absolute value of x is equal to 4, both for x is equal to negative 4 and 4, right? Two answers. It's kind of easy, but yeah, anyway, that's kind of the idea. So I'll let you figure out the other ones there. Okay, then it says, part C, sketch the graph of y equals 1/2 x plus 2 and y equals absolute value of x in the same coordinate system. And then find the area of the region bounded by them. So y equals negative 1x, negative 1/2 x plus 2. No, y equals 1/2 x plus 2. So y equals half of x plus 2. You don't need to use graph paper or anything. Sometimes it's preferable, just get the idea of it, right? So crosses when x is 0. When x is 0 on the y-axis, it's at 2. So let's put 2 right here. Okay, so that's 2. So that's where it crosses. And then its slope is 1/2. That's not very steep, right? This is a slope of 1, so it's half as steep. So something like this. So it goes something like this, right? So it crosses right there. And this is the area that we want, the area bounded by, no, sorry, it goes all the way to here. So we want the area of this triangle. Now, one thing to notice is this is a right angle, right? Where the absolute value of x makes a right angle, because this is a 45-degree angle, y equals x, y equals x. So this is a right angle. That helps us out, because then we could do the area, we could say this is the base, so call this the base, B there, and then maybe this is the height of the triangle, and we know that the area is 1/2 base times height. So what you got to do is figure out where this thing hits the graph, right? We need these 2 points, this one here and this one here. So what you do is you say, okay, for this point, x is negative. When x is less than 0, we got to use this formula. When x is greater than 0, we use this formula. So we have to solve this thing twice, right? So we wanted to know that point. We set the lines equal. So we do it twice, okay? So the first time, let's do it for the negative one, right? Because it's to the left here, I don't know. So we say y equals 1/2 x plus 2, which is equal to, for less than 0, negative x. Solve for x to get that point. When we know x, we know y. And then the second point, we say, okay, there, y is equal to 1/2 x plus 2, which is equal to x. Now solve for x. It's not hard, right? These are easy things to solve. Solve for x, and then once you know x, you know the y value, because y is x or negative x. So y is the same number as the x one, right? If you know the x value, you know the y value, because it's the same thing, just it's always positive. Here you're going to get a negative x, the y value is positive. Then you can figure out the base, which is the length of that side by the Pythagorean theorem, and you can figure out, again, this point here, because you can figure out that distance there, height, because again, it's the Pythagorean theorem, right? Here's the x value, here's the y value. just like over here, we have the x, the y value, the x value. You could use a distance formula, but since it's from the origin, it's really easy. It's just the Pythagorean theorem. Okay, I'll leave you to finish that on your own. But that's the whole idea with absolute values. The trick is to get rid of them. And then you can play the games and say these things equal and finding the areas of triangles and everything. So, all right. Hope that helps.